Our next speaker is Dr. Rico Tabor. He's from the School of Chemistry. He is group leader of the Soft Materials and Colloids Laboratory. His research group studies phenomena at the interface of self-assembly and responsive nanomaterials. His current research focuses on using interactions to control materials, including new photo-switchable surfactants and the charge control of carbon nanomaterials. Thanks, Rico.
I'm going to talk to you about one way we're interacting with industry through a sort of a quite unique new scheme that Monash has developed to support our PhD students. Now, because I'm a chemist and not an engineer, our graphene oxide journey has maybe been a little bit different. We're not the old guard. We haven't been sort of working on carbon nanomaterials all the way through from buckyballs, nanotubes to graphene. I grew up in a surfactant chemistry lab, so most of my research has been looking at novel organic surfactants. We later learned that graphene oxide is fabulously surface active, and so you can do remarkable things with it, like stabilize emulsions and adsorbent interfaces, which turns out to be really exciting for the colloid chemist. And so we work with the dirty stuff, graphene oxide, not the clean, pure graphene itself. More recently, we've been looking at non-covalent magnetic functionalization of graphene, so new applications in water treatment and metal ion capture with obvious results for minerals and mining. And the project we're doing with 3M, which is the GRIP sponsored project, is more looking at soft systems, so turning two-dimensional nanomaterials into 3D structures. Something that Dan has really perfected, and that we're sort of working in a slightly new field. We're also doing some work with surfaces of nanoencapsulation. So the GRIP program, the Graduate Research Interdisciplinary Program, is designed to be a PhD plus. So the PhD student gets added value from their PhD by working closely with an industry company as well as with their academic supervisors. And the specific GRIP that I'm associated with is called CAPMIN, Chemicals and Plastics Manufacturing Innovation Network. And so there are around 20 or so companies involved to this stage. And it's co-funded through this unique mechanism by the Victorian State Government, Monash, PACEA, and the companies involved. They're very focused projects, obviously of interest, strategic interest to the companies involved. And you can see we've got people all the way from 3M, PPG, to small local startups who are trying to grow their research portfolios. So we've got some quite unique skills and companies involved. The benefits for the university are obviously clear: increased visibility, increased opportunities to diversify our portfolios in both research and commercialization. The benefits for the companies are hopefully that they can use us to generate some new IP, some interesting new schemes. You can't hear me, sorry, I'm being waved at. Stand closer to the microphone, you idiot. Okay. The specific project, we're working with 3M. They're obviously one of the larger players involved. This is the student involved, Matt Pottage. He's been working for me for a couple of years through his honours year. He's already published 6 papers, so he's really one of our top students. So these programs really can attract incredibly devoted and very smart students, and we've accosted Dan as co-supervisor on this project just because of his incredible expertise in the field. So 3M are providing project funding. They provide a 3-month internship for the student with the idea at the end of it they'll get out a very qualified recruit who will hopefully consider working for them. State government is providing the PhD scholarship and a big proportion of the GRIP running costs, and Monash obviously provides the infrastructure, environment and tuition for the student. Now clearly I can't tell you too much about the specifics of the project because otherwise 3M will get very upset with me, but I can tell you we're very fortunate in that it's an extremely blue skies project, which is quite unusual. They're very happy for us to do some really transformational research rather than working on a specific product, so we're very lucky to be able to do something quite blue skies. The basis of the project is trying to turn, via graphene oxide, carbon nanomaterials into 3-dimensional structures with very specific surface chemistries, so targeted towards things in catalysis and scaffolds. That's really all I wanted to say to you, just to highlight that there's this opportunity for supporting PhD students within the school through this quite unique mechanism that's maybe a bit different to the other opportunities for interacting with academia. So thank you very much.